Welcome to the Explainer. You know, we hear about a new AI model dropping, like every week. But what if the whole way we're building them is wrong? Today, we're going to look at a totally different blueprint for AI, one that doesn't just fake understanding, but might actually get it. It's called the Semiotic Web.
So let's dive right in. What's the big problem with the AI we're all using right now? I mean, they're incredibly powerful, right? They can write essays, create amazing art, but don't they still feel a little hollow? Like they're just shuffling words around without grasping what any of it actually means?
Well, it all comes down to how they're built. The AI we have today, it's basically a super advanced pattern matching machine. It's guessing what word comes next based on statistics. And it's all happening inside this mysterious black box we can't really see into. The semiotic web, on the other hand, is completely different. It's built to be transparent. It doesn't simulate meaning. It actually encodes it. Think of it like this. It's the difference between memorizing the answers for a test and actually understanding the subject.
Okay, so to really understand how to fix this, we need to take a trip back in time. And I mean way back, like 150 years ago, before computers were even a thing. We're going to meet a philosopher whose ideas are, believe it or not, the key to building a better AI. And that giant is an American philosopher named Charles Sanders Peirce. Now, this guy had an incredible insight. He realized that reality, that the universe, isn't just a bunch of ones and zeros. It's not that simple. He argued that the whole universe is made up of signs, of a much, much richer structure of meaning. So what was his big idea? It's actually pretty simple on the surface. He said that meaning isn't a two-way street. It's a triangle. It needs three parts to exist. First, you've got the sign. That's the symbol, like the actual word home. Then you've got the object. That's the real thing, the physical house. But here's the magic ingredient, the interpretant. That's the context, the feeling, the idea that pops into your head when you hear the word home. It's not just a building. It's a feeling of warmth, of family, of safety. And this is absolutely crucial. Take away any one of those three parts, and meaning completely collapses. It just becomes data. And that is the fundamental flaw with today's AI. They're missing a piece of the triangle. They have the sign, the word, and they can statistically link it to an object, but they're missing the interpretant. They're missing the context. That's why they hallucinate. They're just connecting words without any real-world understanding. They have the dictionary, but they've lost the world. So, a 150-year-old idea about meaning. How on earth do you turn that into a working AI architecture? Well, Peirce laid the foundation, but a whole bunch of other brilliant minds came along and built on top of it. Let's look at who they were. First, there's Arthur Koester. He came up with this really cool idea called a holon. A holon is just something that's a whole thing and a part of something bigger, all at the same time. Think about it. A neuron is a whole cell, right? But it's also just one part of a huge neural network. That network is a whole, but it's part of a conscious thought. Koester saw that everything in the universe is built like this, in nested layers. Okay, next up is someone you've definitely heard of, Tim Berners-Lee, the guy who invented the World Wide Web. But get this, his original vision was way bigger than what we have today. He didn't just want to link documents, he wanted to link concepts. He dreamed of a giant global graph where ideas were connected, not just pages. The semiotic web is basically taking that original, incredible dream and finally making it a reality. So we have the philosophy and the structure. Now we need the physics. That's where Mark Burgess comes in. He created something called semantic space-time. It's basically a coordinate system, a map for meaning itself, so you can see how close or far concepts are from each other. And he also developed promise theory, which is a wild idea. It's a way for AI agents to work together without a central boss telling them what to do. They make promises to each other, creating a totally decentralized and resilient system. And that ties perfectly into the work of another philosopher, Alicia Juaro. Now, we usually think of rules or constraints as things that hold us back, right? But she pointed out that some constraints actually create new possibilities. Her classic example is language. The rules of grammar, they don't just limit what you can say. They're the very thing that makes it possible for you to write a beautiful poem. So context isn't just background noise. It's the framework that creates new kinds of meaning. All right, so we've got the philosophy from Peirce, the structure from Koestler, the physics from Burgess, and the understanding of context from Guerrero. The blueprint is almost complete, but for the final piece of the puzzle, the inspiration comes from the best computer there is, nature. Yeah, a biologist named Michael Levin has done some amazing work showing how all living things learn. I'm talking everything from a single cell to a whole colony of ants. He found that they all use a handful of the same basic network behaviors. And the semiotic web is designed to copy these 5 biological learning processes directly.
First up is something called homing. You can think of this as the network's anchor. It's the ability to always return to a stable, known state of facts, kind of like a compass, always pointing north. This gives the system a solid foundation, a ground truth that can't be easily messed up by bad info. Next, you have inflating. This is the growth part. It's how the network explores and expands by making new connections between different ideas. It's like the system has its own kind of curiosity, always building out its map of what it knows. Number 3 is deflating, and this one is super important. This is how the network cleans itself up. It prunes away connections that are weak or have been proven wrong. It's the immune system for knowledge, making sure the system stays trustworthy, which is a huge problem for LLMs today. Then there is what Levin calls spiky behavior. This is like a lightning strike of insight. It's when the whole network lights up in a big burst of activity to solve a really tough problem. It connects ideas from all over the place to have that eureka moment. It's the system having a genuine flash of inspiration. And finally, number 5 is steppy. This means the system doesn't just learn a little bit at a time. It makes big jumps in understanding. When a new foundational piece of knowledge clicks into place, it can suddenly unlock a whole new set of skills. It's like going from basic math to suddenly understanding algebra. It's a level up. So when you put it all together, you see it's not just a collection of cool ideas. The semiotic web literally engineers all of this into its core. You've got the nested structure of Koestler's holons, the promise-based physics of Burgess, the context creation of Yorero, and all 5 of Levin's biological learning patterns. It's an AI that's not just inspired by nature, it's built using nature's own operating system. Okay, that's a lot of theory, but what's the payoff? Why does this even matter? Well, it matters because this new architecture seems to be a direct answer to some really serious warnings we're hearing from the very people who created the AI we use today. I mean, just look at this quote. This is from Yann LeClin, one of the godfathers of AI. He's saying that the kind of AI he helped create is doomed. And he's not alone. Geoffrey Hinton, another pioneer, is saying the same thing. They're basically telling the world, hey, the road we're on is a dead end. Just making these things bigger isn't going to get us to real intelligence. And this is where the semiotic web comes in. It's like a checklist of solutions to their biggest fears. Instead of a black box you can't understand, you get total transparency. Instead of statistical guessing, you get actual, verifiable knowing. It has real memory, it's grounded in context, and it's incredibly energy efficient. It's exactly the kind of fundamental change these experts are calling for. Which leaves us with a pretty mind-bending final thought. Maybe we've been asking the wrong question all along. Maybe the goal isn't to build a machine that thinks like a human. Maybe the real prize, the thing this new architecture is pointing to, is building a system that can truly tap into and participate in the universe of meaning. The question isn't, can a machine think anymore? It's, can we build a part of our universe that truly understands?